Hi guys, welcome to my channel. Today we'll be going over the Unit 6 Lesson 5 packet. This video in particular is dedicated to solving practice problem 1. So immediately I see that this question is long, so I'm going to annotate as I go. So a student prepared a solution of salicylic acid, a monoprotic weak acid with a molecular mass of 138.123 grams per mole. So they prepared the solution of this thing, and they measured the pH of the solution to be 2.430. The student then evaporated 100 milliliters of the solution and collected 0.22 grams of dry salicylic acid. So let's calculate the Ka of salicylic acid. Okay, so I have to calculate the Ka basically from the pH. Cool. I don't know what salicylic acid is, so I'm just going to abbreviate it as HA. I'm going to set up my rice table. And I'm going to set up my reaction first. I'm just going to use HA in place of salicylic acid. So HA dissociates into H plus and A minus. Okay. I can assume that my initial concentration of H plus and A minus is going to be 0, but I have a problem. I'm not given my concentration of salicylic acid, so I can't really fill out my initial. However, I'm told about this procedure where the student evaporated the 100 milliliters of the solution and collected 0.22 grams. So okay, so basically here is my beaker of solution. We know the volume of the solution, which was 100 mils. And once we evaporate that 100 milliliters off, we're left with a certain amount of salicylic acid. Since I know how many grams of salicylic acid were present in that 100 milliliters of solution by evaporating the solution and collecting the leftover deposit, I can convert the grams of salicylic to moles of salicylic acid. And then I have the necessary information to calculate the molarity of this solution. So because molarity is equal to moles of solute, which in this case is our salicylic acid, over liters of solution, which is 0.1 liters. Okay, so let's do that. Let's convert grams to moles. I'll do that over here. So we have HA. We have 0.220 grams for every 138.123 grams. There's 1 mole. So we get that we have 0.00159 moles of our salicylic acid. Cool. Now I can actually plug this into my molarity equation. Separate that. 0.00159 moles over 0.1 liters. My molarity is equal to 0.0159 molar. Okay, now I have the necessary information to complete my rice table. So I get my initial concentration is 0.0159. Okay, I know that I have some of this present initially and no products present, so we can only shift right. Minus x plus x plus x. My equilibrium is going to be equal to 0.0159 minus x, and x. Okay. Now, typically I would relate these terms using the Ka expression. However, I'm calculating Ka. What I can do instead is use the pH of the solution to calculate the concentration of H+, which is also equal to x. So let's do that. I know that pH is equal to the negative log of our concentration of H+. Rearranging this equation, I get that the concentration of H+ is equal to 10 raised to the negative pH, which in this case is equal to 10 to the negative 2.430. Plugging that into the calculator, I get the concentration of H+ is equal to 0.00371. Great, so I'm going to plug that in to my rice table. Now, we have been ignoring this minus x for a while. However, in this case, we already calculated x. It's not really all like that much of an inconvenience to just calculate the actual equilibrium concentration. So we're actually going to factor in our minus x. And part of that reason is because in this case, x is not exactly negligible. So we get our equilibrium is equal to 0.021, 1291. As we can see, our dissociation of our salicylic acid did have a significant impact on our concentration of on our equilibrium concentration of salicylic acid, to the extent that to the appropriate number of sig figs you can see that change. Like I said, it's not really, in this case, it's not inconvenient to subtract x, so we'll do it. In cases where we would have to like use a quadratic or something like that, we would just ignore it. So that's the distinction that we're really making in this lesson. When it is not inconvenient to take minus x into account, we will do it. Okay, now I can actually calculate my Ka. I always start with the Ka expression. I will plug in my values from my race table. Since the concentration of H plus and A minus are the same, I'm just going to square that, divided by my equilibrium concentration of HA, which we have appropriately calculated. And we get that Ka is equal to 1.13 times 10 to the negative third. And that is how we solve practice problem 1 in the Unit 6 Lesson 5 packet. I'll see you guys later.